Hello and welcome to the next vlog. We are going to be discussing the EMPOWER version 2.5 final release for this version. There's some additional things we'll do for later versions, but as you all know, upgrades don't cost anything. We have been hard at work doing a couple of things. One is taking in feedback and basically identifying areas to make things a little easier to use. And then, of course, we did things to make it also a little more complicated just for fun. So what we're going to do is discuss some of the new features. If you want to see what the other capabilities are, you can go back and look at our previous videos. First, I will mention that we have done a few things to reduce false positives. That, as I've said before, there's no such thing as 100%. So we're reducing the false positives. There was a couple of ands instead of ors in the software. We've addressed what we are aware of. And of course, we're constantly taking feedback. And whenever we receive feedback along with data, that gives us a chance to explore and make sure that we've identified those. Now, I use this technology in the field as well, but I know the real ins and outs. So that feedback is really important when we're doing the work. So again, what's kind of cool about this is what we did is we created a system that works along with the empath. So you can either use this or the empath or both to get all of the features. So this includes the high frequency harmonic analysis, especially for looking at bearing issues. We've produced some information on that in terms of articles. We will be working on, we've already contracted to develop the next book in electrical and current signature analysis. That will be before the end of the year. And that's going to include all of the new stuff we're discovering. A number of research projects in the works. Some of those are joint with other organizations. Some of them are joint with the Department of Energy. And that involves both technologies. So let's go ahead and let's cover some of these new capabilities. So the first one, the easy one, I will show you because I did cover in the last vlog the self-triggering system, and this is the first time it's been done by anybody in any technology. So let's go ahead. What I'll show you is one of the systems that we put together. Now, we're working on a full trending capability for at least the energy data, so you can watch and see if things are increasing. That will come in a couple of more versions. We want to continue moving this along, but we are also working on the continuous monitoring version of the current signature analyzer, or the EMPOWER CMCSA, or continuous motor current signature analyzer. So let's go ahead and, so it says trend data. This will be in the coupling and driven portion. You don't need to have opened anything else. But if I select that and I say analyze driven, it is going to pop up and ask me for first file. This will be my baseline. And then I'll be able to open up second file, and that will be the one that I'm comparing to. So I can do a layover of the two sets of data. Now the new executable is quite sizable, whereas before we were about a 50 megabyte executable. This one is a 500 megabyte executable. In any case, let's see it pop up. Hopefully I'm not lagging by now. I can see I've got the little twirly thing going, and as we've talked about before, gee whiz, if this software doesn't, the video software doesn't hold me up. So it's popped up on my other screen. So this is basically the difference between the prior set of data and the new set of data, but I also get to see this. And even if I increase it, it should increase this as well. We'll give it a second. And then I'll be able to zoom in or do whatever I normally do with my navigation. But as I said, I'm probably lagging by now. There we go. So I've got a full size screen now as well. I can zoom in to specific areas to see what's changed. And we've made the colors so that, one, if they overlap, they're dark. One's blue and the other one's kind of orangish. So they're semi-clear so that when they add together, you see one thing, but they also stand out. So I can see a definitive difference between the old data and the new data. So that will give me a quick comparison between any two sets of data. And it doesn't have to be in the same folder. It can be wherever else. Now, we did talk about the last time the other one, which is the triggering capability. So this here falls under data collection, and it involves, now there's a glitch in this. We've attempted to remove it. It ends up corrupting things. So there's an unfortunate repeat that occurs, but it's more annoying than it is anything else. We're working on that. That should be corrected along with some other features for 2.6. So if I click on Start, it's going to ask me for a location that I want to save data. So I select the folder, and then it'll ask me for the JSON file in there, the nameplate data. Okay, and then when it's set up, it's going to ask for it again. So there we go. Take that one. And then the other thing it's going to do is it will pop up my analytics system. And beforehand, this is one of the things that's kind of annoying, but it temporarily annoying, is this. So we don't want that training time now, or it's just going to start analyzing data without a model. So we want to do, and if it selects a model, end up doing the isolation forest. So the isolation forest is a regression model. The other one that says autoencoder, this is an actual neural network. So we're going to go ahead and I will select that. And what it does is it pops up. This is the fun part, sensitivity. Now, the other thing I want to do is the folder I selected, I will want to have some type of memory stick or something in the computer. That could be an SD card, whatever you want. You do not want to do this on your PC or laptop because it does not do a roll-off, meaning that if you have a lot of anomalies in your system or you set this to be too sensitive, you can fill up a computer really fast. So what you want to do is you want to have this set in the PC or anywhere where you're saving to a location where it runs in. If it fills up, it just ends or corrupts it or stops it, but you'll have all good data in the meantime. So what this is going to do, let's go ahead and we'll select, let's select high sensitivity. Okay, so, and I'm not going to enable smoothing, so I collect a few pieces of data. Now, it's not going to be perfect data, but the idea is to get you 120-second snapshot. So it's going to build a buffer. It's going to then train off that buffer while it's continuously streaming. And then you're going to start the analysis after it builds the buffer up again. So it takes a little bit for it to get running. But what it's doing and what's so unique about it is on your own PC or laptop without connecting to the cloud, it will allow you to build a physical model of the system you're testing. So basically learn what the limits are, and then it will work off of that trained limit. So if something comes along and triggers it off of that trained normal operation, then you will have caught that data during that particular event. So we're not going to enable smoothing that. So I want to deliberately catch a few things. So Enable smoothing gets rid of little outliers and random noise and things like that. Stuff we're not really interested in sometimes, but I don't want to have it set all the time to give you some options. Now I can set up email alerts that we will cover in the manual, and then the save and load models will save the trained model when you're done there. This just pops up these two screens here. So when we go ahead and we start, now I can say, okay, how much time do I want to train? So for purposes of getting this going, we're going to say about 6 seconds, because it's going to take a little bit for it to train. So right now, it's going to, the data I'm taking, by the way, is off this laptop. It's now building that buffer up and it's going to train. Chances are I'm lagging pretty good by now. So meaning me, but it's taking separately data in, and it's going to train off that. So that will take 130 seconds or 2 minutes, plus then the 6 seconds for training. So all of this is automatic. So if I want to set the laptop on a piece of equipment, say I want you to train for an hour or two or whatever, recommend you plug in as well, then you can walk away, just let it run. And yeah, so we just finished this, and this is now the final executable. It's been tested, and we've had a couple of things, so we delayed it a week for release. And then we are going to just have to complete a few sections of the manual describing both these systems, and then it releases basically on Monday the 14th. So we're going to go ahead. There it goes. It's trained. It's set thresholds and everything else for that training. And by the way, if it loses, like if the equipment shuts off somewhere along the buffer, it'll grab that data. So it's a lagging buffer. So that means that it'll catch it at some point during the event. It's supposed to timestamp it for when that anomaly occurs. We're still testing a little bit of that. But right now the delay is it's building that buffer up again. So it's gotten rid of the training data, and now it's working off of new data. There we go. It's now active. And I left it relatively sensitive, so let's see if it detects anything. I'm going to try something here too. So it will continue operating until it sees something working differently. There we go. So it's caught an anomaly already, and it's saved that anomaly. So it's detected that anomaly at that point in time. It has now saved it to memory, and it's basically restarting, looking for the next anomaly. So it's going to restart again, and it's going to watch for the next anomaly to occur. Now this is a slight change we made because the snapshot, what was occurring, and you can see it, by the way, it's also labeled it as anomaly. It'll tell you where it's located as well. And if I want to view the snapshots, I can pull this up, and it's actually grabbing a few. So here we go. There's the next one. Okay, 0412. Oh, those are prior ones. Okay, so this is the first one. It's the one we just collected. It's built it back up again. There's where I have disconnected everything, so it's seeing an anomaly. It's also identifying the current is below a certain level, so it's saying it's off. So it's basically alerting me as to what those conditions are. And this will build back up again. So it's grabbing a series of snapshots as a direct result. And this is where I said each one of these is 15 megabyte. Okay, so it will now catch up in just a second. You can see the current starting to come up. And then it's going to, again, work off of the data. So there was a delay, and what it did is it took and it saved it to the time. So that's 17:53:40, so that would be 5:53, and it is 5:54 right now. And then fractions of, and then seconds. So it grabbed those, and now you can see it stopped because it has a series of set of data from when the anomaly was occurring, so that I can now take a look at it. So we're going to go ahead and stop this. Now that's the that is basically the system that was set up for the other, and you can see it took a little while because it's looking at stream. I had unclamped the data and then reclamped it back on, and so that was in the stream, and it waited because it's analyzing all of that data continuously, so it does lag. It is unique. We are working on speeding it up so it's more real time, but it gets you in the ballpark. Plus, we can then look at the data. So let's go ahead and we will close this. Okay. The other one is just taking snapshots, but if you have an alert or something like that. So let's go ahead and we're going to go and open. There's all our anomalies in that data set. And we are going to go ahead, and this is the last set of data taken, right there. So let's see what it looked like. Okay, wanted that JSON file because that has all our settings in it. And yes, we kept the background again. Basically, so there's data there if you want to go back and take a look and see what's functioned, what hasn't functioned, what it's calculating. You can see that right there. So we're at 100 millivolt per amp. So I've got the clamp set at 20 amps, and that is 100 millivolt per amp, a CT ratio of 1. Here comes everything here. And like I said, it's not the fastest software. It's not supposed to be. Because it's doing all this work and all these calculations in the background. That's the other reason I have the screen there, so you can watch it occurring. You can see I'm using, in this case, TensorFlow, which is the neural network that I just used. So autoencoder is a neural network. So here's our data off this power supply. And we're going to pretend it's a machine. So let's make sure I have nameplate information, pretend nameplate information in here. We also have our harmonics, so we'll take a look at that next. Let's go ahead and we will auto-analyze. That'll come up with some false positive stuff, but kind of planned it that way. So this is where it was still off and it hadn't come back up again. So we're now able to see what was going on. So I have bearings and stuff like that in here from a little 3/4 horsepower motor. Of course, we're doing just sound off the laptop. Almost there. And then I'll show you one of the changes we did make as well. And it's because, when we're out in the field, I normally get all the bearing information. I normally get all of the rotor bar and stator slot data. As you and I both know, that's not always available. So we now have it set up so that if we see where that isn't there, it won't make false positives because of missing data. Something that did occur on occasion before. And somebody did ask me a question. No, we can go down to no load on testing. Somebody said something about 50% of load. That is somebody else's technology. Neither the empath system nor the EMPOWER system requires more than no load in order to test. So we're often testing unloaded, sitting on a bench, and that's it. Okay, so it went ahead and it's pretending it's seeing a bunch of stuff. And then we can now go, there's our watt data. And we'll give that a second to catch up. Okay. And then here is our losses, the analysis portion. And then we can come back here. Let's take a look at the harmonics. That's going to go ahead and pop up first. It's going to pop up the FFT out to 22 kilohertz. But you can see, even with this, we do have it. Now, if I go ahead and I compare it, this is not particularly harmful. So the harm index is going to be relatively low. High frequency, if now I see peaks at about 40 dB down or higher, then I know I'm going to have problems with things like brushes and things like that due to ground. Harmonic analysis is going to allow me to take a look at the current itself. And all of this can be saved as an independent. Give it a second here. There we go. And that'll allow me to even come all the way in to see what this all looks like. Now, what does the data look like that's the current off of my laptop? Why didn't you go? There we go. Must have been too small. There, see? That's what the current looks like for this. My other laptop looks a little different. So there's that, and then we can take a look and see what the overall harmonic, and then we can even save this then. So you can see that the actual current amplitude for each of the harmonics is here, and it'll show as a total harmonic distortion as a percentage when that screen pops up here in a second. There we go. Now we're going all the way out to like the 467th harmonic. And then there's the other screen that allows me to put in some notes. But you can see, so there's some super harmonics out there. I want to look at some of that. So let's get in here. And there's, just over 6% total harmonic distortion. Matter of fact, if I look at this down here, when that pops up, you can see that says 6.23, so it's 6.23%. I also have some even harmonics because there's some square wave present, and then some other stuff. And if I come way out, you can see this keeps going. Now I can move this around a little bit if I've gone off scale, or if I want to make sure it shows up right, because when I print, it's going to take these exactly the way I show them on the screen, turn them into PDFs, and then put them in a report. So I can also, the save here is to save that figure itself if I want to do anything else. So let's go ahead and we'll get out of this. I can close them either up here or off the close button. So there we go. Now, so that I have that, and then if I want to take any two sets of data, I come here. Yes, I can run those in parallel. Yes, each function will run. So this is where it caught the anomaly, right? So let's go ahead and we'll compare that anomaly to a different anomaly. Oh, wait a minute, that's not from today, is it? So let's go ahead and we'll take a look at anomalies from today. So let's go ahead, we'll take this anomaly. Oh, we're going to compare the other two. So let's go ahead and see what those look like as compared to each other. Pop off on the screen, then I'll drag it over. But that's basically, those are the new features, allowing us to take a look and see what's going on. Yeah, so the other one was something completely different. Let's go ahead. I'm going to do one more thing here. I'm just going to go ahead and open up so we'll do another trend analysis. Let's look at two readings from today. So we're going to take a look at the anomaly, the last one, the one we just looked at. So we'll grab that one. We'll grab two up. So let's grab this one here. We're going to go ahead and grab 412. So let's grab further back. Let's grab, say, this one. Somewhere where we were watching the current coming down and then coming back up again. Let's see if those look any different. So let's go ahead and we'll take a look at that comparison and then we'll end it here. These upgrades come as no additional charge to our existing customers. So if you're using the EMPOWER, you get the upgrade. We stick with that with all of our tech, so that you're not having to worry about budgeting. We want you using it. So here's the distinction, and so it looks like it was back up and running at that time too. But let's get in zoomed. You can see that the 2 points were at about the same load because there's not a significant difference. Okay, so that's what basically this signature looks like in a spectra. I can take a look at other machines as well, but that is about it. So yeah, this is the new one. We'll release it on Monday. All of our existing users will receive an email that basically prompts them to be able to download it. Right now, we've taken the downloads off the website. We've had some aggressive hacks by, we'll just say, unscrupulous competitors that we know. We get an alert. As a matter of fact, if you try to crack the software, I get an email telling me from your email address. But in any case, fine and dandy. That's basically the system in a nutshell. If you have any questions whatsoever, reach out directly. Again, if you're an EMPOWER user and you move to the Empath, there's a good solid discount there. And then there's also the combined system. So if you want to buy both, there's a steep discount as well, a significant discount to have both systems. So you can have the high frequency harmonics and a second set of data. I run both systems off the same laptop, so you can easily do that. As a matter of fact, I have them both plugged in the same time. They both take different types of data. And then I have the full capability of the power quality options of the Empath, and I have the full capabilities of some of the unique properties of the EMPOWER, and they work really well together. I just spent yesterday doing that on a large piece of equipment, and that will actually be my case study for later. In any case, have a great day. This is the vlog. And for those users who catch this, this is coming on Monday. I just have to finish up, or the team, I should say, just has to finish up the manual, and then you have all that capability. So have a good one, be safe, and we will talk more later.